All right. Welcome back, you cool cats and kittens. I think that's the saying. We are going to work through these problems. Just going to be hustling through, so pay attention. First one says find the lateral, that's everything but the bases, and the total surface area for the following prism. When I'm working on prisms and pyramids, I focus on the bases first. The base is an equilateral triangle, and they tell us each side is 4. So that's going to be 4, 4. I told you guys to get really good at this. Get used to just dropping the height and cutting it in half right away. When you do that, this becomes a 30, 60, 90 triangle, and this would be 2 root 3. So the perimeter would be 4 times 3 is 12. The area would be 1/2 times 4, because that's 4, times 2 root 3. That would be 4 root 3. So the perimeter of the base is 12. The area of the base is 4 root 3. And then the height, we need the height, is 7.2. So for the lateral area, that formula is pH, and that is going to be 12 times 7.2. 12 times 7.2 is 86.4, but they say round to the nearest whole number, so it's going to be 86. The total surface area is going to be 86.4. Don't use a rounded number to do the next thing. Plus 2 bases. The bases are 4 root 3 each. So that's going to be 86.4 plus 8 root 3. And I get 100.256, or that rounds to 100. And we're done. Next part. The following is a square pyramid. Now, guys, a square pyramid could be a square base, but not be a cube. Square, that could be a square base and not be a cube. So it is a square pyramid, a square and a rectangular prism, but we know, because they called it a square pyramid, that this is a square. This may look like a rectangle. I know it looks like a rectangle. I know. But we don't go by what the looks, we go by what we're told. They told us it's a square. It's a square. That means that this is also a square down there. So I am going to use the square as the base of my pyramid and as the base of my prism. And we are asked to find the surface area of the figure. What you need to understand is that this base is not a surface. So my plan here is going to be the lateral of the pyramid plus the lateral of the prism plus 1 base of the prism. This base on bottom is the only one that's an actual surface. This top base of the prism, not a surface. So I'm not going to do pH plus 2b. I'm going to do pH plus 1b. So my formula here is going to be 1/2 PL for the pyramid plus pH plus 1b. This is going to be on the pyramid. This is going to be on the prism. All right. So let's execute that. Well, I'm going to start by drawing the base. The base is a square that has a radius of 3 root 2. So if that is 3 root 2, then the whole thing would be 6 root 2. So we're talking about a square that has a diagonal of 6 root 2, which means each side of the square must be 6. So the perimeter would be 6 times 4, which is 24. And the area is going to be 6 times 6, which is 36. Those are numbers that I need. All right. Then we go back over here. It tells us that the lateral edges are 5. Every lateral edge is 5, prism and pyramid. Lateral edges are 5. So this is going to be 5. And all of the rest of those will be 5. And this is going to be 5. This is where it's tough. We know, so let's focus on this blue triangle, the parts that we know. We know this side's 5. We know this entire length here at the bottom is 4. We need the slant height. The slant height starts at the apex and goes down the middle of the side. So we have a right triangle here with a hypotenuse of 5. Oh, wait, that's not 4, sorry, guys. How long is the side of the square? 6. That's 6. 6. Since the entire base edge is 6, that means half of it is 3. That is a 3, 4, 5. That is my slant height. My slant height is 4. So, our answer is going to be 1/2 times the perimeter, which we got earlier, 24, times the slant height, which is 4, plus, so that's the pyramid, plus pH, 24, and then the height of the prism would be 5, so 24 times 5 on the prism, plus 1 base, which is 36. So this would be 48, this would be 120, and this would be 36. Make sure I get this right, 120 plus 36 plus 48, and I get 204. So overall, our surface area is 204. That's a hard problem. You had to do a lot of things there. That's a high-level question, no doubt about it. A right cone, guys, every shape we've done has been right shapes. Right prisms, right cones. It just means that the top and bottom are perpendicular to each other. We haven't done any other thing, okay? And they're directly above or below each other. A right cone, so a cone, where the apex is right above the center. That's all that means. And that's pretty much all we're going to do in this class. Has a diameter of 17 feet. Well, I don't care about the diameter. I care about the radius. The radius is half of that, which is 17 over 2. And a slant height of 9.6. Find the lateral. The lateral is pi RL. So for this problem, be pi times 17 over 2 times 9.6. 17 over 2 times 9.6. And that is 408 over 5. Don't forget your pi. But we're going to round to the nearest whole number. So type that in, times pi. And that is 256.353. So it rounds to 256. Okay. That's it. Find the total surface area of a cube with a cylinder cut out. Cube with a cylinder cut out. It doesn't matter how you do it, but I'm going to do my cylinder from top to bottom. So there's a cylinder cut out of the cube. The sides of the cube are 8. So all the sides are 8. And the diameter of the cylinder is 6. I don't care about the diameter. I care about the radius, which is going to be 3. All right, so those are my numbers. Surface area. So we're going to find the total surface area. All right, this can be pretty tricky. If I were to draw all of the surfaces, I would have 1, 2, 3, 4 squares that are lateral, that are going around the shape. 2 squares that are bases, but those squares each have a hole in them. Now, here's the tough thing, is this cylinder is a hole. We can see the lateral part of that cylinder. That would be a long rectangle. These are the surfaces I have to account for. The 4 squares without a hole, the 2 squares with a hole, and then I have to add on the lateral of the cylinder, because that is a hole. When you cut through something, you create new surfaces. This is on the inside of the cube, but when we drilled through the cube, it exposed the inside. That is not part of the original surface. The original surface did include these 2 circles, though. On the original surface, these circles were filled in. So we have to come up with a plan that accounts for the fact that there are two holes on the top and bottom, and that we can now see this lateral surface of the cylinder. So my plan is going to be the total of the cube minus two circles. Those got to go. Those aren't there anymore. They're gone. Plus the lateral of the cylinder. That lateral is on the inside of the cube. The inside is not a surface until you expose it. But it has been exposed, so it is now part of our surface. The total of a cube, and I believe it's on your formula chart this way, I have never given you this formula, is 6s squared minus 2 pi r squared, the two circles, plus 2 pi rh, the lateral of the inside. So this is going to be 6 times 8 squared minus 2 pi times 3 squared plus 2 pi times 3 times 8. So that is going to be 64 times 6, that's 360 plus 24. 9 times 2, 18 pi. And then 6 times 8, 48 pi. That's going to be 384 plus 30 pi. So we actually, although we lost volume, we actually gained surface. We lost 18 pi, but we gained 48 pi. So the surface area of this shape is actually more than the original cube. Well, they want us to round to the nearest whole number, so 384 plus 30 pi would be 478.248, which rounds to 478. Next question. This is a cylinder that has had a chunk of it removed. You can picture it like a birthday cake or something, and you remove a piece of the cake. And we have to think about, what does that mean? Well, what surfaces do we have? We have a circle with a piece missing. We have a circle with a piece missing, top and bottom. We have the curved part would make one long rectangle. And then we have these two rectangles. Those are the surfaces that we have to account for. Which of these surfaces was not there before the cut? That's something you have to ask yourself. Could you see the lateral of the cylinder? Yes, the lateral of the cylinder, which wraps around, yes, that's a surface. That's where the icing is. But could you see this rectangle or this rectangle before the cut? And the answer is no. Those are on the interior of the cylinder. And before you cut the cylinder, they are not a surface. After we cut the cylinder, they are a surface. So we have to make a plan that accounts for the fact that I can now see two cylinders that I couldn't see just a minute ago. Also, I have to account for the fact that 90 degrees of the shape is gone. So let's think about that. So the original cylinder is 360 degrees and we lost 90. So we still have 270 degrees. And that's out of 360. A full cylinder is 360. That leaves us with 3/4 of the original cylinder. So my plan is going to be 3 times the total of a cylinder. Not 3 times, 3/4 times the total of a cylinder. The total of a cylinder is 2 pi RH plus 2 pi R squared. That'll give me all of the pieces that were on the original cylinder. But there are 2 new pieces, and they're rectangles, plus 2, and that's going to be RH because the radius is like the length, or the width rather, I guess, and the height is like the length. This is the length and width of a rectangle, and there are 2 of them. So this is my plan. This will give me all the curved parts, the sector on top, the sector on bottom, and the curved lateral surface around the cylinder. This will give me the two rectangles. So on this problem, we have R equals 10, H equals 32. So it's going to be 3/4 times 2 pi times 10 times 32 plus 2 pi times 10 squared. So we're doing 3/4 of all of that plus the two rectangles. 2 pi, nope, no pi, 2 times 10 times 32. I would love for you to do as much of this as you can without a calculator. This would be 2 times 10 times 32 would be 640 pi. This would be 100 to be 200 pi. Add those, that's 840 pi. And we're doing 3/4 of that. So if you can't divide by 4, try dividing by 2. If I divide by 2, that's 420 and 2, and then I can divide by 2 again, that's 110 and 1. And then times 3 would be 330 pi. Over here, don't forget this part, that would be 640. So there's my answer, but they probably want us to round. Yeah, it looks like it's rounded to the nearest whole number. So 330 pi plus 640 is 1676.7, which is 1677. I messed up. Something's wrong. Let me check the answer key. Number 5, maybe I have the wrong answer in brown there. 2619. So I messed up somewhere. Oh dear. We have 270. It's 3/4 times 2 pi RH plus 2 pi R squared. 32 times 10 times 2 is 640. 100 times 2 is 200. So 640 plus 200 is 840 times 3/4. Oh. Why did I mess up? Oh. Well, I'm really sorry. So that is incorrect. So 840 divided by 2 is 420. Divided by 2 is 210. Oh dear. Times 3 is 630. So I said 110. So it's 630 pi. So 630 pi plus 640. And that is 2619.2 or 2619. So one mistake. My bad. All right. Next problem. Find the surface area of the bread box. We did this together in class, not an easy question. The cross section is a square with 1/4 of a circle. Cross section just means if I were to slice this, get like a knife and cut off a piece. What flat shape? A cross section is a flat shape. And they're saying it's a square and 1/4 of a circle. So this is a square, and this is 1/4 of a circle. That's what they're saying. We know that these sides are all 8. They tell us this is 8, and that would be 90 degrees. Anytime you have a shape like this with two bases, we are going to treat it like a prism, which is pH plus 2b. It's going to feel a little weird here, but we can do it. So the perimeter would be all of this. Well, let's do the perimeter. That would be 8 plus 8 plus 8. So that's 4 times 8 plus 1/4. And let's write down this formula here. The circumference of a circle is 2 pi r. So we're doing 1/4 of that, 2 pi times 8. So the perimeter is 32 plus 4 pi. This part of the circle is 1/4 the circumference of the whole thing. So the perimeter of my cross section is 32 plus 4 pi. Now I need the area, the base area, capital B. The square part is going to be 8 times 8. And the circle part, it's 1/4 of a circle. The area of a circle, remember, is pi r squared. So it's going to be 1/4 of pi times r squared. That's going to be 64 plus 64 divided by 4, 16 pi. So that's capital B. So now we need to do pH. What is h? H is the distance from between the bases. So there's h, 16. So h and all of this, so this is B, that's P, h is 16. So our answer is going to be pH 32 plus 4 pi times 16 plus 2b, 64 plus 16 pi. And we're going to round that to the nearest thousandths. I'm going to type this in exactly like I wrote it. 32 plus 4 pi times 16 plus 2 times 64 plus 16 pi. pH plus 2b. Please do it right. Yep. So I got 941.5928, which is 0.593. There are other ways to solve it. None of them are as easy as this one. And this is not easy. But this is the easiest of the ways that I know to solve it. Number 7. The following cylinder and cone have the same surface area. The diameter of the cone is 12. I don't care about the diameter. The radius is 6. Find the radius of the cylinder. So they didn't say they have the same radius. They said they have the same surface area. So we need to find the surface area of the cone, which is pi RL plus pi r squared. That is pi times 6, L. This is a right triangle, so this would be a 6, 8, 10, and that's my slant height. Pi RL plus pi times 6 squared. So that's 60 pi plus 36 pi. So this is 96 pi. All right. Well, the cylinder has the exact same surface area. The cylinder formula is 2 pi RH plus 2 pi r squared. What do we know? We know the S. We know it's 96 pi. We know H, but we don't know anything. We want the radius. That'd be 2 pi r times 8 plus 2 pi r squared. Well, this is going to be a harder one. First thing I can see is I could divide everything by 2 pi. 96 divided by 2 pi is going to be 48. The pi's cancel out. This is going to be 8r. The 2 pi's cancel out. The 2 pi's cancel out. Plus r squared. Every term I could divide by 2 pi. Now it's a factoring question. Subtract 48, I get r squared plus 8r minus 48 equals 0. First move for factoring is make one side 0. What factors of 48 subtract to equal 8? 1 and 48, 47. 2 and 24, 22. 3 and 16, 4 and 12, got it. So it's what factors of 48, I should have been writing them down, 148, 2, 24, 3, 16, 4, 12, ding, 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 ding. It's going to be 12 minus 4. So it's going to be r minus 4 and r plus 12. So r equals 4 or negative 12. Can a radius be negative? No. So the answer is r equals 4. Fun question. All right. Ooh. Oh, okay. Even though this is true, false, you should be able to draw this. I included blank space. Okay. The last picture is an accurate drawing of the first picture. So there's the drawing. Do I want to spend the time to draw this? Here's the things that you have to be able to do. You have to draw every line you can see. You have to make sure you don't draw any lines you can't see. And I am asking you to shade the tops. So is that all done in this picture? Yes. So you will have to do this on the test and quiz. All right, that's a wrap.